So when determining whether the function is linear or exponential, you want to look at what's occurring on the y, but also you want to do a quick check for the x's. Notice they're all increasing by 20 as far as the x coordinate, which they're talking about ORP here. So we can essentially just look at the y's. If the x's weren't changing by the same amount, then we need to take both into consideration. And that's a tricky one. Now, in this case, let's see, is it increasing or decreasing by the same amount? Well, if it were additive, it would be really subtraction. It would really be subtraction. More specifically, we could go to our calculator and see if we do 61 minus 38, we get 23. And then does it look like it's decreasing by about 23 every time? No, especially down here, it's decreasing by only 2. So I'm definitely leaning against the idea of it being linear. So let's see what it would be for the exponential. Now notice the difference in the wording. They say for every 20 mu v, is how you would read that, I think, increase. So they're talking about up here where it's increasing by 20. So for every one of those, is the purification time decreasing? Yes, but is it by a fixed amount or a common ratio? Now a fixed amount, that'd be linear. So it doesn't make sense to say it's exponential because of a fixed change. So that concept doesn't even make sense, or go with the exponential model. So we know right away it's option D, but it is because of that common ratio. If you're curious what that common ratio is, you could take any of the y coordinates and divide it by the one to the left of it. So that gives us about 2/3, right? Let's say we do the same thing, 6 over 9. Oh, we're getting the same thing consistently, 9 over 15, right around 0.6, 0.7, right? Even if we do the biggest ratio of 38 divided by 61, I guess really this one of the smaller ratios, but the idea is bigger numbers, we still get about 0.6. So that makes it a common ratio, and again, answer option D.